Hi everyone, this video is going to be talking about polynomial inequalities, and this is day 1 of 2 days where we'll be looking at polynomial inequalities. And for starters, let's just do a refresher on what it means to be an interval notation, what these inequalities really mean. So it asks us to graph the following on a number line, and if you can see right here, some of the critical points we're looking at are -5, 1/2, 3, and 6. So I'm going to put 0 right in the middle. We're looking at -5. We're also looking at positive 1/2. So I'll say 1/2 is right here. We've got 3. We've got 6. In this first interval right here, we're saying that whatever we're looking at can be any number up to -5. So from -infinity to -5 means that it could be any number up to -5, but not including -5, which is why we put an open circle. So it's anything less than -5 will work. Okay? In the next interval that we have here, we're saying that the variable, what we're looking at, can be exactly equal to 1/2 because we have a closed bracket right here. And it could be anything between 1/2 to 3, but not including 3. So we shade in from 1/2 to positive 3. And then in our last interval that we have here, we're saying that what we're looking at can be the number 6 or above, but it can include 6. So it would be 6 or higher. Okay, and then we shade in to the right because it could be any number greater than or equal to 6. So now question number 2 says, solve the following inequality using a factor table. We'll talk about what a factor table is shortly. But in order to solve anything that is a polynomial, we need to get everything together on one side. So the first thing I'm going to do is get everything together so that my leading coefficient is positive. Because x to the power of 3 is the highest exponent, I'm going to move everything over to the left side. So I'm going to subtract 2x squared. I'm going to subtract 14x, excuse me, and I'm going to add 16. So in doing so, these are all gone. So I end up getting x cubed. This turns into -4x squared. Here I get -9x. And here I get positive 36. And I have to use the inequality sign. This is greater than or equal to the number 0. Okay, because everything on the right side subtracted out to give us nothing. Okay, so then remember, if it is a polynomial expression, a polynomial equation, excuse me, or in this case, inequality, we need to factor this. So I'm going to use the factor theorem, and I'm going to plug in factors of 36 right here to see if I can find some values that will work when I plug it in to give me a remainder of 0. So the first factor of 36 that I'll try is 1. So I will type in right here 1 cubed minus 4 times 1 squared. I don't need brackets here, but I'm going to put brackets in because when I want to change numbers, I will need a brackets eventually, and it's just going to be easier for me this way. Minus 9 times 1, and then plus 36. And if you look here, I don't get a remainder of 0, so that means that 1 is not a factor. Well, let's try -1. So here I'll put in -1, -1, and -1. And -1 is also not a factor because my remainder here is 40. So again, we want factors of this 36 that we have here. So I'm going to try 2, but I'm going to try -2 first since the negatives are already in there. So I will plug in -2. I still don't get a remainder of 0, so that doesn't work. So let's try +2 instead and see if that will help. When I plug in +2, I get a remainder of 10, not 0, so that's not going to work either. So again, we're looking for factors of 36. So let's try, sorry, I don't want to delete that 36. Let's try 3. 3 is a factor of 36. So I'll try 3. I'll put a 3 in here, and I'll put another 3 in here. And when I do that, look at that, I get a remainder of 0. So that means that when I plug in 3, it will work. So that tells me that x minus 3 is the factor. So here we can say f of 3 equals 0. So therefore, x minus 3 is a factor. So let's go ahead and do our synthetic division. So I'll start with 1, -4, -9, and 36. And because f of 3 worked and x minus 3 is a factor, I'll put in 3 here. So let's go ahead and do our division. So I'll bring down the 1. 1 times 3 is 3. Add that, I get negative 1. Negative 1 times 3 is negative 3. Add that, I get negative 12. Negative 12 times 3 is negative 36. I get 0. So now we can say that this right here is going to be x minus 3 times x squared minus x minus 12, and that will be greater than or equal to 0. Well, I can factor this a little bit further. So when I factor this expression right here, I would end up getting x minus 4 times x plus 3. Okay, I'll copy down this greater than or equal to 0. And I will also copy down our original factor of x minus 3. Now I'm color coding this on purpose. As of now, nothing is new. The only thing that's new is we have a greater than or equal to symbol instead of an equal symbol. But now what this means is that any one of these values that I have here, any value of x that I plug in here, as long as I get greater than or equal to 0, is a possible answer. So like, for example, if I plug in 10 here, I would get 10 minus 3 times 10 minus 4 times 10 plus 3. And 10 minus 3 is positive 7, 10 minus 4 is positive 6, and 10 plus 3 is positive 13. And that is a positive times a positive times a positive. It's greater than 0. That's a possible value I could get. There are infinite values that I could plug in for x that would work. So what I need to do is find out all those infinite values using like a number line. So that's where the factor table comes in. So the first thing I'm going to do is I'm going to identify what would be like my critical points. So here my critical points are at x equals 3, at x equals 4, and at x equals negative 3. Just like if I were to solve an equation, my solutions would be 3, 4, and negative 3. Okay, so for the next thing that we're going to do, I'm going to show you 2 different ways to do this. So maybe cut your paper down the middle for the rest of this right here, so that way you can kind of see all the both ways that we're going to do this. So if you see here, our first critical value, let me put in 0 for starters. Our first critical value that we're looking at is x equals 3. Our next one is x equals 4. And our next one is x equals negative 3. Next thing we're going to do is we're going to draw a dotted line down each one of the critical points. It doesn't have to be a dotted line, but I just personally prefer to do that. And I'm also going to draw a line right here to separate my work on the side from the number line. Then this is where the factor table comes in. It asks us to use the factor table. Well, these x minus 3, x minus 4, and x plus 3 are all factors of this inequality that we're trying to solve. So I'm going to make a table with all of these factors. So my first factor is x minus 3. My next factor is x minus 4. And then my last factor is x plus 3. And because we're talking about things that multiply together to give us 0, we're either dealing with positives or negatives. It doesn't really matter what the numbers are themselves. But for example, if I have a positive times a positive times a positive, I would get a positive which is greater than 0. If I have a positive times a negative, for example, then I would have still a positive which is greater than 0. I'm just giving random examples, but let's say, for example, we have a positive times a negative. That would be a negative, so that would not be greater than or equal to 0. Okay? All right, so I'm going to move these down just a tiny bit so I have a little bit more space right here. What I'm going to do next is I'm going to think of numbers that fit within each one of these like little intervals that we have here. So here, I'm going to think of a number that is smaller than negative 3. So I'll try like maybe negative 4. In this section right here, I'll try a number between negative 3 and 3, which is 0 would work. In this section right here, I would think of a number between 3 and 4. So I'll try 3.5. And then in this section right here, I would think of a number bigger than 4. So I would try maybe like 5. Okay, so let's talk about what happens. If I were to plug in negative 4 into x minus 3, a negative 4 minus 3 would give me negative 7. This would give me a negative value. If I were to take 0 and plug it in for x here, then it would be 0 minus 3, which would still be a negative value. If I were to take 3.5 and plug it in for x, I would get positive 0.5, which would now give me a positive value. And if I were to plug in 5 for x right here, then I would have 5 minus 3, which is positive 2, which would give me a positive value. Okay? So we know if I just had x minus 3, it would be negative all the way until I get to positive 3 right here, and then it would become positive afterwards. Okay? All right, in the next one that we have here, we have x minus 4. If I were to plug in negative 4 in for x here, I would have negative 4 minus 4, which is negative 8, which would give me a negative value. Here, if I plug in 0 for x here, I would have 0 minus 4, which is also negative 4, so I would have a negative value here. Now, if I were to take 3.5 and plug it in for x here, this time it would be 3.5 minus 4, which would still be a negative value, so I'll have a minus sign right here. And then lastly, we have 5 here. When I plug in 5, I would have 5 minus 4, which is a positive value. I get positive 1, so this is a positive value. So notice for x minus 4, everything will be negative until I get to that 4 right here. Okay? And then lastly, the last one that I have here is x plus 3. So again, if I take negative 4, I plug it in. Negative 4 plus 3 is negative 1. So negative 1 is a negative value, so I'll put a negative number here. If I take 0 and plug it in, 0 plus 3 would be positive 3, so this would be a positive value. If I take 3.5 and plug it in for x here, 3.5 plus 3 is 6.5. That would also be a positive value. And if I take 5 right here and I plug it in right here, 5 plus 3 is 8. That is also a positive value. So now I'm going to extend this a little bit more because what's happening here is that this entire inequality that I'm looking at is the product of x minus 3 times x minus 4 times x plus 3. I'm going to squeeze this in. So essentially what I'm doing here is I'm multiplying a negative by a negative by a negative. Well, 3 negatives multiplied together give us a negative. So this means here that this whole entire thing, the total inequality is going to be a negative. Here, I'm going to do a negative times a negative, which is a positive, times a positive, and it's going to be a positive. Here, I've got 2 positives multiplied by a negative, which would give me a negative. And here, I would get 3 positives multiplied together always gives me a positive. So that means that within this section here, this is always going to be negative. Within this section from here to here, I'm always going to have a positive here. From here to here, I'm always going to have a negative. So this section here is negative, and from here to here, this section is positive. Now, the last thing that I want you to be aware of, 2 things actually, because this here says greater than or equal to, that means that x can be equal to 3. X can be equal to 4. X can be equal to negative 3. If this just simply said greater than, then x would not be able to be equal to these 3 values, and then we would instead put open circles, okay? And because this says that it has to be greater than or equal to 0, that means that we are looking for positive values. Well, where is it positive? From negative 3 to 3, because that's what we figured out here. And it's also positive from 4 on, because that's what we figured out right here, okay? Okay, I want to show you one last way to do this factor table that might be a little bit easier. If you're not comfortable, I suggest you use the first way. But once you get comfortable, it gets a little bit tedious. So here's another way to do this that might be a little bit easier. So again, I'll put 0 here. I know that I've got negative 3 is one of my critical values. I have positive 3, and then I also have positive 4. Okay? Close the circle, close this circle, and close this circle right here, okay? Then what I'm going to do is I'm going to draw in my dotted lines. And I'm also going to place all of my factors. So I've got x minus 3, I've got x plus 4, or sorry, x minus 4 and x plus 3. Well, this first factor right here of x minus 3, we know that no matter that the breaking point between positive and negatives is going to be at 3 because 3 minus 3 is 0. Anything bigger than 3 right here will have to be positive, and anything smaller than 3 will have to be negative, which is exactly what we have right here. So you don't have to actually plug in numbers to figure out these signs. In x minus 4, the critical value is 4 because 4 minus 4 is 0. Anything bigger than 4 will be positive. Anything smaller than 4 will be negative. So here's my critical point here. Anything bigger is positive. Anything smaller would have to be negative all the way down, okay? And then lastly, we have x plus 3, and negative 3 plus 3 gives us 0. So our critical value here would be at negative 3. Well, anything smaller than negative 3 would be negative, and anything bigger than negative 3 would be positive. So you can figure out these values on the factor table without actually having to do plugging in numbers. And then same thing, 3 negatives multiplied together give us a negative. 2 negatives multiplied together give us a positive. One negative multiplied together is a negative, and all positives will give us a positive. So this works between negative 3 and 3 because it works here, and it also works here. Okay, so then lastly, the last thing that we need to do is write our solution. And our solution is going to be the intervals that are shaded in. So from negative 3 to positive 3, including both of those values, as well as from positive 4 to infinity. So this is our solution, and that's how you do inequalities. Let me know if you have any questions. Otherwise, I'll see you in class. Bye.